Hey everybody, this is Larry. This is, of course, day 26 of the March Leetcode Daily Challenge. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about this one. We are almost at the end of the month. Time flies, and yeah, today I did a lot actually. I went to the gym. I did a little bit of upper body, none of the big lifts, just a little bit of accessory, and try to work on my lower back by doing Supermans and stuff like this. Just trying to and suitcase carry, and then I kind of warmed up for a mile, and I ran 8 by 100 strides over like half an hour or so. So it's kind of getting my legs loose and body loose and everything. So I know that I've been talking about my injury a lot, my foot injury. I feel like I'm at 90% now. It's still not 100, but enough for me to kind of keep working out and kind of start pushing a little bit. I have the New York Marathon in 7 months, 8 months. So yeah, time flies, and training will have to start soon. So we'll see. But today, let's take a look at today's problem. We have 2033 minimum operations to make a Uni-Value grid. What is a Uni-Value? I guess we'll probably find out. You're given a 2D integer grid of size. In one operation, you can add x or subtract x from any element in the grid. Can you make all the grid equal? If it's not possible, return -1. I don't get it. You can make it all. You go to 4, okay. Or you go to 3, okay. Yeah. I mean, so first of all, right, the first thing we can do is to check whether it's even possible. And it's possible if every number mod x, the input x, is the same number, right? If not, then you know, no matter how you subtract or add, because you can think about x as in you're adding or subtracting by some value of x, right? And after that, my intuition would just be to take the median value in the thing, right? And this is something that comes up maybe here and there, but the idea is, okay, so we have a grid, right? But it doesn't have to be a grid. It's just an array, really, right? Because there's nothing that deals with height or width or whatever. And I am pulling up my drawing board real quick to kind of show you the median or why median works, right? Where my pen at? Yeah, so I'm just going to draw an array. I'm too lazy to draw a matrix. But the idea here, right, then is that let's say you have a number line, right? Don't know why I wasn't drawing. Let's say you have a number line, right, and you have any numbers to the left, to the right, right? And for the purpose of this problem, right, we already know that. So let's say we already sorted the numbers, right, and we have a number line, right, and we already did the thing that we said where we mod every number by x, and yeah, right, we mod every number by x, and they're the same. Then it is possible. Then from that, we just choose the number in the middle, right? It doesn't. And keeping in mind that this is the median, not an average, right? And what I mean by that is that, you know, you could have numbers that are very close or very far, and it doesn't really matter as long as it's median. I didn't count, so pretend that's the median. And the reason is because, right, so let's just say we look at the median, right? That means that without loss of generality, if you choose, let's say x is 1, right? So it's a little bit easier to kind of talk about. But if x is equal to 1, well, what happens when you move this number to the right? And also for the purpose of this, let's just say they're odd numbers, right? Odd numbers meaning that there are some k numbers to the left of this and k numbers to the right, so that they're the same. It is only one number in the middle. So let's say that we want to move one number. Let's say we almost like by contradiction. Let's say we start from the median, we move to the right one, right? Well, what happens? Well, that means that k numbers will go subtract 1, right? Or it's a very awkward drawing, but these k numbers, they all go subtract 1 for each, oh sorry, plus 1, right? Because they're now one farther away, so that means that you're plus k. In the meanwhile, all these k, it's going to be minus 1 because, well, they moves one distance closer, right? However, keeping in mind that this, since we're at the median, and so the median is going to be one farther away, just because, well, we move farther away from the one in the middle, right? So as a result, this is always going to be worse, and that's basically your proof right there, right? Is that on the left side, if you move one step, then you know you're one step farther. On the right side, you're one step closer, so you subtract 1, but then the median is whatever, right? One step farther. And of course, you if let's say you have 2 numbers instead, then you can pick any. Oh, sorry, if you have even numbers instead, then you can pick any numbers in the middle, but you could just choose one. It doesn't matter, right? And the same logic here as well, right? Is that if you instead choose a number that, let's say the median are these 2 numbers, right? And then you choose one to the right of them, then to the right, there's going to be some k-ish numbers plus 1, or k plus 2, I suppose, including the 2 median, right? And then k numbers on the right side is going to be minus 1, and of course if you sum that up, it's going to be bigger than before. So that's how you kind of prove that it is the median value that you care about, and yeah, and that's it really. So yeah, so first let's go for the grid, right? So we can check that it's the same, right? So we just look at the corner, right? What's a good variable name? I don't even know anymore. T for target, right? Right, so for x, oh, I can do it. Yeah, okay, fine. Right, so if grid of ij mod x is not equal to t, then we return -1, right? Because as I said, we can't go to all of them. X cannot be 0, right? Because you can mod by 0, or I mean, it would just give you an error. Okay, so otherwise, then we just kind of calculate how many moves it takes. There are a number of ways you can normalize it by doesn't really matter, I think. I mean, I think the order of operations doesn't matter, and what I mean by that is that you can convert it to moves first, or you could sort and then get the median first. I don't think it matters that much. You can also do a linear median finding thing. I'm not going to do that because I'm lazy, but you can if you want to, right? So maybe here I'm just going to, in fact, I'm a little bit lazy, so I'm just going to flatten the way, right? It's not the most efficient thing in the world, but whatever. In terms of space, right? But like I said, you could do a median, like a linear median algorithm. You can Google that. It is annoying, obviously. That's why I'm not doing it. But yeah. So we can sort, and yeah. And then this is going to be the number that we want to go to, right? And then now we have to just do the math, right? So median is equal to this, and then maybe you could either go for the grid again or go for the array. It doesn't really matter, right? But it is always going to be possible, and then it is just equal to the median minus grid sub ij, the absolute value, right? So that's going to be the delta, and the delta will always be a multiple of x from what we said, right? So we could just divide by x, and that's it. Unless I'm wrong, then I'll be very sad, but it looks okay. So let's give a quick submit. Maybe I missed a thing, but yeah. I mean, like I said, you can definitely do a median finding thing. I'm a little bit lazy, but I think for me, the more interesting thing is just the concept, right? About the median and all these things. Yeah. The people just do the, what was the editorial say? I mean, I knew that was going to be median, but do they have a median finding code, or they just sort? Oh, they just sort anyway. Prefix sum, suffix sum. That could be interesting. 2 pointers, man. Do they get paid by the word or something? There's just so many. Okay, they don't have a linear median finding, is what I was gonna say, which is honestly, I feel like that would be the best thing. But yeah, anyway. That's all I have for this one. Let me know what you think. Actually, let me go over the complexity. I mean, the complexity is just n log n, right? There's sorting, and n is of course r times c. Yeah, and the way that I did is O of n space. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.